Hi students, in this short video I'm going to show you the one of the valuation techniques which is used in investments, and that is the calculation of present value and the net present value. So you can see in this example that the bond is for £1,000, £1,000, and the coupon rate is 10%. That means the return will be 10% for the next 5 years, and the rate of debt, or the rate of return, is 8%. Now that means I will get £100 in year 1, in year 2 I will get £100, in year 3 I will receive £100 again, year 4 and year 5. In year 4 I will receive £100, and in year 5 I will receive £100 plus the £1,000 which I invested. So I will get £1,100 back. Now one way to work out the present value is divide them by their discount factor, and if you know the formula to calculate the discount factor is 1 over 1 plus r raised to the power n. N is the number of years and r represents the interest rate, or the cost of capital, which is 8% in this question. So what I can do is 1.08 raised to the power 1, 1.08 raised to the power 2, 1.08 raised to the power 3, 1.08 raised to the power 4, and 1.08 raised to the power 5. I will have to add all of them because I will be receiving all of them. So if I really see I'm getting £500 as an interest on this £1,000 plus the £1,000 back, so it's altogether £1,500 I'm going to receive. £1,500, that is the cash flow in 5 years' time. But the working of all of this tells us the present value of this £1,500, and the present value, if you do the calculation, comes down to 1,079.85. So that means the £1,500 which I'm going to receive in 5 years' time, or over 5 years' time, the value of that 1,500 in today's term is £1,079.85. The other method you can use is 100 the cash flows. These are the cash flows, and multiply them by the discount factor. So this is year 1, 2, 3, 4, and 5. The discount factors are 0.926, 0.857, 0.794, 0.735, 0.681. You can work these discount factors out using the formula, which is 1 over 1 plus r raised to the power n, or you can simply follow the discount factor table. When I'll multiply all of them, it comes down to 1080.3, which is very close to what I have already calculated. The only reason I have different answer in two calculations is because of the decimal places, but that will always appear because I have only taken up to 3 decimal places in the second calculation. So this is how we calculate the present value. Now in the second example, I'm going to show you how to calculate the net present value. And in this example, you can see that the investment is £1,200. If you invest £1,200 today, over the 5 years, you will be receiving 430, 460, 460, 380, 250, and 120. So in the last year, you will be able to sell this project and you will receive 120 pounds towards it. That is the salvage value or the scrap value. Now I can multiply these cash flows. Since they are already given, I will just write discount factor over here, and I have already calculated the discount factors. So I will, in the first year it is always 1. In the second year it will be multiplied by 0.797. Second year it will be 0.7, oh, it's 0.893. In the second year it is 797. Third year it is 0.712, 0.636, 0.567. If I add all the so I need to now multiply and add them down. So I can write them over here. It is 1200. So 1200 is in negative because that's the cash outflow. 383.99, 366.62, 327.52, 241.68, 209.79. Now if I add all of them, remember there's a minus figure. The rest of the 5 figures are in plus, and the final answer is 1529.6. This is the present value. Net present value, sorry, net present value. And the rule is, if the net present value is a positive figure, then we should go ahead and invest in this project. I hope this is clear. Thank you very much.